Welcome back to Easy to See. In our last class, we obtained an overview of K-map and also the concept of grouping of adjacent cells. And as I promised in my last class that in the following classes, I will be simplifying Boolean expressions for 3 variables and 4 variables using K-map. So today I am here with the class of simplifying Boolean expressions for 3 variables for sum of product and product of sum, both the formats. So let's get started. First we will simplify a few examples for SOP or Minterms, and then we will simplify for POS or Maxterms. So here in the first example, as we can see, a function y is given and y is a function of 3 variables a, b and c. And on the other side of that equation, we can see there are 3 terms. But all the terms are not min terms, only the first term where we have all these 3 variables. So that is the min term and rest 2 terms are not. So this is actually not a canonical form. If this type of non-canonical format of any Boolean function is given, then in the first step, first we have to transform that to its equivalent canonical form. So this is the equivalent canonical form of that given function. I have a separate class on transformation from non-canonical form to canonical form. You may refer that class. Now in the next step, what we will do, we will draw that K-map. Since here we have 3 variables, so we will have 2 raised to the power 3 means 8 cells in that K-map. Next we will write all the variables and their corresponding values that we have learned in our last class. And then in the next step, we will fill the cell number. Cell numbers are the equivalent decimal numbers corresponding to each min term. That also we are already aware of. Now what we will do, we will take the help of the truth table from where we can decide that which cells will be filled by 1 and which cells will be filled by 0. Since this is a sum of product format and this function is given as a sum of min terms, so for all these min terms, those corresponding cells will be filled by 1 and rest of the cells will be filled by 0. Now here we have 3 min terms a, b, c. The corresponding min term is m7. Then we have a, b, c bar. The corresponding min term is m6. And then we have a bar, b, c. The corresponding min term is m3. So in that K-map, we will have 3 cells which will have 1 and then rest of the 5 cells will have 0. Now next is to simplify this Boolean expression, and for that we need to group the adjacent cells. And for grouping, first we will see whether we can group 8 adjacent cells or not. 8 adjacent cells means that is called octet. And since we are working with 3 variables, so here we have 8 cells. So that type of grouping may be possible. But here since this function is defined by 3 min terms, so in our case, that type of grouping is not possible. So if that is not possible, then we will check whether any quad is possible or not. Quad means it is a group of 4 adjacent cells. And again, since this function has 3 min terms, so quad is not possible. Then if that is not possible, then we will go for pair. Pair means it is a group of 2 adjacent cells. Since we have here 3 min terms, so there is possibility of pairs. Now we have to see whether there are adjacent cells or not. As per the definition of adjacent cells that we have learned in our last class, we can see these 2 cells are adjacent cells. So we will group them. And then we can see that we have a 1 in that K-map which is not part of any group yet. So what we'll do, the logic is if we have a single 1 in case of SOP or min terms that is not yet part of any group, and if it has adjacent cells with which it can form a group, though those cells have already formed group, but still by taking that single 1 we can form a new group. So though this 1 is already part of this group, but since this 1 is not yet part of any group, so by taking this 1 and this 1 we can form a new group. Now after completing the groups, next step is simplification, and that we will do group wise. So first we will take this group, and what we can see here that in this group the value of AB is what? Value of AB is 1 1. And value of C is what? Value of C that changes from 0 to 1. That means the terms are A, B, C bar and A, B, C. So if we apply Boolean algebra, then it will be A, B and C plus C bar, and C plus C bar as per Boolean algebra, that will give us 1. That means finally we will have A, B, and this C plus C bar will be dissolved. This variable will be dissolved for that group. We will go by the same concept, but here we will not apply Boolean algebra. Directly we will eliminate or dissolve that variable. So here, since AB is not changing value and that value is 1 1 and C is changing value, so C will be dissolved, and finally for that group the final term will be AB. And then we will go to the next group, and that is this group. So here what are the values? Here we can see that C has value 1 and that is not changing. And if we look at the values of AB, then B is also fixed, that is 1, and A is changing value from 0 to 1. So what will happen here? Here A will be eliminated and B and C will remain in that simplified term. So here the second simplified term will be from here C and from here B. So it will be B and C. So in the final function or modified or most simplified function, we will have two terms, that is AB and BC, and since this is a SOP form, sum of products, so it will be AB plus BC. And this is how we simplify by using K-map. So always we will remember or use this relation AX plus AX bar, that will be equal to A, and that I have already discussed in my last class, where X is the variable which changes value and A is the rest of the variables that remain constant. Now we'll move on to the next example, where we can see that we have a function which is defined by three variables A, B and C, and here we have 8 minterms. So in the first step we will draw the K-map. Here since 3 variables, so 8 cells we will have in that K-map. Then we will complete the variables and their corresponding values. Then we will mark the cell numbers, and that is not mandatory. If we can remember the cell numbers, and that will be developed as we will practice more, marking of cell number will no more be needed. So as we can see in this function, we have all the minterms from 0 to 7. That means all the cells will be filled by 1, as we have minterms here. So these are the ones. Next we will simplify the Boolean function, and before that we will group adjacent cells. Now first we will check for octet. So 8 adjacent cells, and in this particular case, as we can see, we have all the ones in all the cells and all the cells are adjacent cells. So here octet is possible. Now simplification. Again the rule of simplification is we will follow this equation. Now we will check whether any variable is changing value or not, and we will go by variable. So we will take A first. So here the value of A is 0, then in the next cell is again 0, and then in the third cell the value of A is 1. So A is changing value from 0 to 1. So A will be dissolved. Now B here has value 0 and then B is becoming 1. So B is also changing value, B will be dissolved. And again C is changing value from 0 to 1. So C will be also eliminated or dissolved. Or we can think this way also, that between these two cells A remains same and that value is 0, so A bar, and B is changing value, so B will be eliminated from these two cells. And again between 3 and 4, this third and fourth cells, B is changing value from 1 to 0, so from these two cells also B will be eliminated and A will be left behind, but here value of A is 1, so here it will be A, and when these two will be added, again A plus A bar, so that value will be 1, and here C is changing value from 0 to 1, so that variable will be eliminated. So for this particular Boolean function, the most simplified form or answer will be 1. Now we'll move on to the next problem sum. Here we can see a Boolean function is defined by 5 terms, and all these 5 terms have A, B, C variables, and since we are solving or simplifying for 3 variables, since all these terms have all the variables, so all these terms are minterms. And this is a canonical form. So here we don't need any transformation. So directly we can apply. First we will draw the K-map. Then we will complete the marking of the variables and their corresponding values. Then we will complete the marking of the cells, which is not mandatory. And then we will take the help of the truth table. And from there we can easily map the minterms and their corresponding decimal values as well. Then we will see which cells will be marked by 1 as per the given minterm. So A, B, C, that means this M7, then we have a b c bar, that means m6, then we have a b bar c, that means m5, then we have a bar b c, that means m3, and then we have a b bar and c bar, that means m4. So all these cells, corresponding cells, will be filled by 1 and rest of the cells will be filled by 0. Now the next step is the grouping of the adjacent cells. So first we'll check for octet, but since we have only 5 minterms, so octet is not possible. Then we will go for quad. So here quad is possible. As we can see, we have these 4 adjacent cells, so they can form a quad. And then we will see whether any more quad is possible or not. No, it is not possible, because apart from these 4 cells or ones, we don't have any more set of 4 adjacent cells. Then we will go for whether any pair is possible or not. Still we have a one which is not part of any group yet, and by taking that one and this adjacent cell, or this one, we can form a pair, though this cell or this one is already part of a quad or a group. Now in this K map, as we can see, we have 2 groups, and next we will simplify group wise. So first we will take the quad, and here we have 3 variables, and if we assess the variables and if there is any change of values or not, we can see here that a, between these 2 cells, a remains same, and that is 1. So 1 means it will be the real value of that a, and then b is changing value from 1 to 0, so that variable will be eliminated. And if we assess these 2 cells vertically, that quad, then we can see here c is changing value from 0 to 1, so that variable will be eliminated. And from this quad, what term we are getting finally is only a. Now we will go to this pair, and in this pair we can see here that a is changing value from 0 to 1, so that variable will be eliminated, and b remains same, and that value is 1, so it will be in its original value. And then corresponding c value is also 1 corresponding to this pair, so here with b we will have this variable c. So from this pair the final term is bc, and these 2 will be added. So for this Boolean expression, the most simplified form will be a plus bc. So one thing we have noticed here, that if it is a group of more number of adjacent cells, then after simplification we will have less number of variables. So here from quad, the final term that we have obtained here, it has only one variable, single variable, and from the pair it was a group of 2 cells, that means less number of adjacent cells compared to quad. So in the final term we have more variables compared to quad. So first 3 examples were on SOP. Next we will simplify a few examples on POS, product of sum, which will be in the form of Maxterms. So as we can see here, the Boolean function which is given, that has 3 variables and it is defined by 4 Maxterms. Though we already know that minterm, it is actually AND operation between the variables or product. So when all these variables individually will have value 1, then the value of this function will have value 1. Now suppose if we have another minterm in that function, say a, b bar, c, then when a will have 1, c will have 1, and b actually will have 0, so that the b complement or complemented version of that variable will have finally 1, and this minterm will have finally 1. So for that combination 1 0 1, this function will have value 1, and that logic we apply in case of K-map also. And that's why when we are expressing a Boolean function by minterms in the K-map, those corresponding cells we fill by 1, and also we group those ones only. But in case of POS, what happens? It is actually represented by Maxterms. So suppose we have one single Maxterm a plus b plus c, and in case of SOP we actually check that for which combination of those terms the function value will be 0. So here, since between all these variables we have OR operation or summation, so when all these variables individually will have 0 value, then only the value of this function will be 0. Otherwise, if any one of them will have 1, then the function value will become 1. Now in that function, if suppose we have another Maxterm, say again a plus b bar plus c, so for that Maxterm, when a will have 0, c will have 0, and b actually will have 1, so that the complemented version will have 0, then for that combination the function value will be 0, and that logic will be applying in case of K-map also. So in when we are solving for SOP or we are filling the cells of the K-map for max terms, we will focus on the zeros, and each zero will correspond to each max term. So in the first step, we'll draw the K-map, then we will complete the marking of the variables and their corresponding values, which is same as Minterms or SOP. Then we will complete the marking of the cells, which is same as SOP or Minterms. So here in the given function, what are the max terms? 0, 2, 4, 5. So 0, 2, 4 and 5, and correspondingly for those max terms, the corresponding cells will be filled by 0 and rest of the cells will be filled by 1, and we will also group the adjacent cells based on zeros. So here the cells corresponding to 0, 2, 4, 5 are filled by 0, and then rest of the cells are filled by 1. Then the next step is grouping of adjacent cells. So here first we will check for octet, which is not possible because we don't have 8 zeros here. Then we'll go for quad, but here though we have 4 zeros, but all those 4 zeros are not adjacent cells, so quad is not possible, but pair is possible. So between these two cells one pair is possible, and also between these two cells another pair is possible. And then we will simplify group by group. From this group what we can see is value of A is 1 and value of B is 0, and value of C is changing from 0 to 1. So C will be eliminated. Here the concept is opposite to Minterms. So since A value of A is 1, so we will be taking the complemented value of A, and value of B is 0 means it will be the real value of B, and here we will have OR operation between these two variables. And then we have the second group where A remains same and that is 0, B is changing value, so that will be eliminated, and C also remains same and that value is 0. So in the second term we will have two variables, or that will be represented by two variables A and C. So here A the value is 0, value is 0 means the in the term it will have A, and for C also value is 0, so that variable will be represented by C, and we will have OR operation or summation between these two variables. So here the most simplified form of that given Boolean function or expression will be, so this is a product of sum format, and this is the way how we simplify by using K-map for max terms. Next we will move on to the next problem, where again it is for POS, and what we can see here we have all the 8 max terms. So we will first draw the K-map, then we will fill all the formalities will complete, and since we have all max terms, so we don't need to think much. All the cells will be filled by zeros, and then we will see what type of groups are possible. So since all the 8 adjacent cells are filled by 0, so an octet is possible among all these 8 cells. And what happens here is if we evaluate these two cells, then A remains same and that is A bar, and B changes value from 0 to 1, and between these two cells A remains same, that is A, and also B changes value. Now since this is POS format, so we will multiply A and A bar this time, and that will become 0. And when we evaluate C variable, that is also changing value from 0 to 1, so that will be eliminated. So for this type of function the most simplified answer will be 0. Now we will move on to the next problem sum. So what we can see here is a function which is defined by 3 variables, that is defined by 2 terms. This is a non-canonical POS format. So first we have to transform to its equivalent canonical form. So this is the equivalent canonical form. The concept we have already learned in our last class. And now what we can see here is we have 3 max terms in that given Boolean expression. So first max sum, then A plus B bar plus C, and that is M2, and then A plus B bar plus C bar, and that is M3. So what will happen here is those 3 cells will be filled by zeros and all other remaining cells will be filled by 1. Here I have marked only those cells which will be filled by 0. So here what we can see is that octet is not possible and also quad is not possible. So only option we are left with is pair, and that is possible because we can see these two cells are adjacent cells. So between these two cells one pair is possible, and there is one more zero which is not part of any group, and that can be grouped together with this cell, though that is already part of another group. Now if we take this group, first group, so what we can see here is A has value 0 and B is changing its value from 0 to 1. So B will be eliminated, and what value or variable we will have for A? It will be A, because we have value 0 here and we are dealing with POS. Now C, value of C here is 0 and that is not changing. So here again the variable that we will write is C. And for the second group, the value of A is 0 and value of B is 1, and those values are not changing. So in the second term we will have A, and for B we will have B complement or B bar, and the value of C is changing from 0 to 1, so that variable will be eliminated. So here the most simplified answer of this Boolean expression will be A plus C and A plus B bar. These two are sum and then product of these two terms. So this class was about the simplification of Boolean expressions using K-map for 3 variables. In the following classes, I will be discussing the simplification technique for 4 variables K-map, and also will have the knowledge of don't care condition. Till then, stay tuned. Thank you.